Find the area of triangles below. We note that in the first case, the angle A and the sides B and C are given. We're given with two sides and the angle between them. In the other example, the angles A and B and the side C are given. We're given with two angles and the side between them. In both cases, the triangles are fixed by the information we're provided with. Our job is to find what we need in order to calculate the area. I start with the first case. If I could calculate the altitude from vertex C because I know the length AB, I would be able to find the area. Let's call this length H. We note that H divided by B is equal to sine A. Because A is given and B is given, we can find H. If we cross multiply this equation, we see that H is equal to B sine A, which becomes 5 sine 60 degrees. The area is H times C divided by 2. This is 1/2. For H we can put 5 sine 60 degrees, and for C we can put its value, which is 8. This becomes 20 sine 60, which is root 3 by 2, and that is 10 root 3 centimeters squared. In the second case, we can draw the altitude from angle A on side BC. Let's call this altitude H. Let's note that this H is different from the H we used in the previous problem. I can easily calculate H because H divided by C is equal to sine B, and as a result H is C sine B, which is 8 sine 45 degrees, which is 8 root 2 divided by 2, which is equal to 4 root 2. I now need to find BC, which is A. From the sine law, I realize that A divided by sine A is equal to C divided by sine C, which means that A divided by sine 60 degrees is equal to 8 divided by sine of the angle C, which is equal to 180 degrees minus angle A minus angle B. We can simplify this equation and cross multiply to get A is equal to 8 sine 60 degrees divided by sine 75 degrees. The area of this triangle is half of the altitude which lands on A times A, and this is 1/2 the altitude times A, which is 8 sine 60 degrees divided by sine 75 degrees. If we use our calculators, we see that the area is approximately 20.28 centimeters squared.